Part 3. What have we not done with radicals yet?
Divide.
No, we multiply and divide. We haven't
Added.
add and subtract. So that's where we're at with part 3 here, is we need to add and subtract. Now, okay, so another piece of information to add to your brain about radicals, and in order to add and subtract, normally in algebra, what has to be true in order to add and subtract? We have to have what we call like terms. So we're going to talk about like radicals, okay? Like radicals have the same index and the same radicand. So we're looking at more specific than we would have been with multiplying. Multiplying, they just had to be the same type of index. So square roots with square roots, cube roots with cube roots. Like radicals, they have to be the same. So we can add a square root of 5 with a square root of 5, but we can't add a square root of 5 and a square root of 2. Okay? So only like radicals can be combined with addition and subtraction. Okay? So let's look at some of these examples. Now, you'll notice the directions. It's add and subtract, but it says rewrite each expression in a simpler form. Okay? Square root of 20 minus square root of 600 minus square root of 125. Are any of those like radicals? They're all square roots, yes. But do any of them have the same number under the square root sign? No.
Any calculator?
You probably will want a calculator by your side. Yes, I should have said that. I meant to say that at the beginning of class. I forgot. Okay. You're going to want a calculator by your side, and another big hint will be, I would suggest you have a blue paper by your side. Okay. You guys know what I mean when I say blue paper, right?
Do you have an extra?
I do. There you go. Okay, so with that in mind, as it stands, square root of 20 minus square root of 600 minus square root of 125, I can't do anything with it. However, do you think we get to finish it, just leave this problem as is and move on?
I think that's a good idea.
No. That'd be nice, but what are your thoughts? What about the square root of 20?
Nope.
It's not.
Definitely.
Is it a perfect square? No, it's not a perfect square. However, does it have perfect squares in it?
Yeah.
It does. What perfect square, go to your blue paper if you need to, divides into 20? 4? 4 divides into 20 from my list, yes. So let's work with what we were doing the other day. Okay, square root of 20 is 4 times 5. We picked 4 because it is a perfect square. Okay, and then 5 is just a leftover piece. Simplify that with me. What do you know about the square root of 4? It becomes 2. What about the square root of 5? It stays square root of 5. Good. Let's do that with each piece of this problem and see what happens. Okay. Square root of 600. As I said, have a calculator by your side if you need to divide any of them. Scan your blue paper. 600, there's an obvious one in my brain, but that's my brain, not your brain. 600 would divide by 100, yes? Yeah, it also divides by 25. It also divides by 4. But I want to go big. It's go big or go home. So, 600. We're going to write it as 100 times what? 6. Okay, well, let's go ahead and simplify that. What is the square root of 100? Not 100. 10. And then the square root of 6 will stay the square root of 6, yes? Okay. Let's check this next one out. Square root of 125. Is it a perfect square? It's not on my list, is it? That's where I always check. But don't make your classmates do this for you. Use your brain and think. You got to do this on your quiz next week. 125, does it divide by anything here? 25? If I have 125 in my pocket, could I maybe have all quarters? You know. So minus 125 is 25 times how many? 5. Okay, carry the minus sign down. The square root of 25 is 5. That's going to go out front. What goes under the radical? 5. Okay. So, as you can see, your first job on these is simplify the radicals. Okay? Now, am I done with this problem? Why not? Do I have any like radicals?
Yeah.
Yeah, what do I have?
5, 5.
Yeah. Right there, I have a square root of 5 radical and a square root of 5 radical. Can I put those together? Most definitely. What do you think 2 square root of 5 minus 5 square root of 5 is? More specifically,
Negative.
-3. Maybe you said the negative. I just wasn't hearing the negative at first. But 2 minus 5 is going to make it -3 square root of 5. What about the minus 10 square root of 6? Carry it down to your answer. Okay. So we've got 2 square root of 5 things, or terms, sorry. I put them together. That's no different than saying what is 2x minus 5x. Okay. 2x minus 5x is negative 3x. 2 square root of 5 minus 5 square root of 5 is negative 3 square root of 5. Can I go farther? No, because now I'm at a square root of 5 and a square root of 6. Those are not like radicals because they don't have the same radicand under them. So we stop there. Questions, comments, thoughts?
So, how did you get the -3, the -3, the square root of 5?
Okay, so I had a 2 square root of 5 and a minus 5 square root of 5. And so it's the idea of 2 minus 5, and then the square root of 5 is still there.
Okay,
Does that help?
that helps, I guess.
Okay, so it's just, the key is these are your square root of 5 terms. So you're taking like the coefficients in front of them, the numbers in front of them, and adding or subtracting. Okay?
Okay.
Okay, let's look at B. Where do you think I'm going to tell you to start?
Cube root.
Okay. Or just in general, I mean, as it stands, do any of these go together?
No.
No, so in general, I'm going to tell you to simplify them. See what happens, see if then maybe some do go together. Okay. Square root of 20. We already talked about this today. 20 divides by 4. So we're going to simplify this. 20 is 4 times 5. When you take the square root of 4, it becomes 2 outside. So 2 square root of 5. Okay. Minus. How awake are your brains this morning? What'd they do to us? They put a cube root in the same problem. It's not very nice, is it? Okay. So now, you gotta shift your brain for a moment. Cube root of 16. Go to your cube root column on your blue paper if you need to. Is 16 a perfect cube? No. But does it divide by a perfect cube on my blue paper? It divides by 8, doesn't it? Okay. So, 16 is 8 times what? 2. Now, make sure you have that little 3 in there signifying it's a cube root. What is the cube root of 8? It's 2, yes? It's the first thing on my blue paper, or can your calculator tell you that? Yeah. So cube root of 8 is going to become 2. Where do I put that 2? Outside. And then we're going to have the cube root of 2 under the radical still. Okay. Carrying down my plus sign. Cube root of 250. Well, now we're getting big. First thing I'm doing is I'm going to my calculator, my blue paper. Is 250 a perfect cube? It is not. Okay? So start looking. Does 250 divide by 216? Does it divide by 125? Does it divide by 64, 27, 8? Does it divide by any of those? Divides by 125, doesn't it? Okay. And remember, that's just putting it in the calculator, right? Do you get a nice whole number out? If so, it divides by it. So cube root of 250, I'm going to say it's 125 times how many? There's 2 of them. What is the cube root of 125? Yeah, if you count down your paper, 2, 3, 4, 5. It is 5. 5 goes outside. The 2 stays under the cube root. So it's the cube root of 2. Don't follow my mistake there, okay? I know some of you saw it before I erased it. And one more term, minus square root of 5. First of all, they went back to square roots, didn't they? Is 5 a perfect square? No. Does it divide by any perfect squares? No, it doesn't. 'Cause the only thing you can divide by is 4. Does 5 divide by 4 nicely? No, not with a whole number answer. So guess what? The square root of 5? It just carries down. Okay. Now what?
The 2s and the 5s.
Okay. So we have not one set of like radicals, but we have 2 sets of like radicals, don't we? Okay. So we know that 2 square root of 5 goes with minus square root of 5. Guesses, thoughts on what 2 square root of 5 minus square root of 5 is? No? One of the guesses I expected to hear. She says 2.
1 square, or just the square root.
What's the invisible number in front of this square root of 5 here at the end? A 1, yes? Okay, so there's an invisible 1 there. This is no different than saying what's 2x minus x. If I say what's 2x minus x, I'm saying, okay, what's 2x minus 1x? And it is 1x, or x, right? So what's 2 square root of 5 minus 1 square root of 5? It's 1 square root of 5, or we can just say square root of 5. Okay, and we already talked about the fact that these cube root 2's are going to go together, aren't they? Now, what do we have there? Check carefully. We have a negative 2 cube root of 2 plus 5 cube root of 2. 3, because negative 2 plus 5 is a positive 3 cube root of 2. Okay? Do these pieces add together? No. So my final answer is going to be square root of 5 plus 3 cube root of 2. You're catching on, right? It's really not a whole lot different than we've already been doing, is it? Are we still using our blue paper and calculator and simplifying radicals? We are. Okay. Okay, let's look at C. They did it to us again. There's cube roots in there. It's also a random square root thrown in there. Just realize you're going to see this in Sabbath, right? They could very easily throw in bits and pieces. Okay. Cube root of 2,000. Well, officially, my paper doesn't go that high. Okay. But 1,000 is the top one on my paper. That's a good hint. Did you try the cube root of 2,000 on your calculator to double check? Okay. Make sure you know how to do a cube root on your calculator. Cube root of 2,000, you get some lovely decimal, right? So it doesn't work. But what do you think 2,000 divides by? 1,000. So let's break this up. Cube root of 2,000 is going to be what? 1,000 times 2. What is the cube root of 1,000? 10. Because 10 times 10 is 100, times another 10 is 1,000. So the cube root of 1,000 is 10. That's going to go out front. What is the cube root of 2? Cube root of 2. So first term, we have 10 cube root of 2. Okay. Plus square root of 2. First of all, we're switching to square roots. Do we know the square root of 2? No. And it's smaller than my square root of 4 there. So square root of 2 just stays square root of 2. Minus cube root of 128. Well, it's not on my blue paper. So my calculator is going to give me a decimal. What are you asking yourself? What are you checking? Does 128 divide by 125, 64, 27, or 8? Divides by 64. Okay. So this is going to be the cube root of 64 times what? 2, because 128 divided by 64 is 2. What is the cube root of 64? 2, 3, 4, according to my chart, right? So that's going to be a 4 out front. And then what's the cube root of 2? Cube root of 2. I obviously must have had an obsession with, I feel like there's a lot of 2s. Well, 2s and 5s on this assignment I'm doing, or this lesson.
All things divisible by 2.
Okay, guys. Can I do anything to finish this problem off?
Yes. Cube root of 2 minus 4.
Okay. We have two terms that both have cube roots of 2's with them, right? So 10 cube root of 2 minus 4 cube root of 2. What's 10 of something minus 4 of something?
6 of something.
6 of something. And my something here is
Cube root of 2.
cube root of 2. So 6 cube root of 2. And then what? Plus square root of 2. He's the only square root in the problem. Nobody else goes with him, but you can't leave him off. So 6 cube root of 2 plus square root of 2. Okay. Getting the hang of it? Okay. Well, officially, we already learned our multiplying and dividing rules, yes? But here's the deal. Now that we know our adding and subtracting rules, we kind of have to put them together. Because there are problems you have to be able to add or subtract and also multiply or divide, usually multiply, within the same problem. So in this bottom section, it's talking about multiplying binomial radical expressions. A binomial being an expression that has bi being 2, like a bicycle has 2 wheels. Binomial has 2 terms, okay? So multiplying things that have 2 terms. And you'll see on each of these examples there are 2 terms involved. Okay, look at A. Officially it says find the product. Square root of 6 times the quantity 5 plus square root of 3. Okay, you guys have been in algebra for a bit. You successfully passed Algebra 1. You made it to Algebra 2. We've been in Algebra 2 for over a semester. What are we going to have to do here?
Distribute.
Right? We have that one term out front, and we're going to have to take that square root of 6, and we're going to have to distribute, right? And then if there's any adding at the end, we'll add at the end. So, what is the square root of 6 times 5? Yeah, square root of 6 stays under the radical. 5 is not under a radical, so we just kind of stick them together. I heard you guys put the 5 out front, so good. So that's 5 square root of 6. Then I'm going to carry down my plus sign. Square root of 6 times square root of 3.
15. Nope, that is not. Oh my gosh.
Right idea,
So
wrong math fact.
stupid.
Square root of 6 times square root of 3, square root of 18. So remember to multiply? They just have to both be, in this case, square roots. So square root of 6 times square root of 3 is square root of 18. Okay? Can I add them as is?
No.
No. Do either of them simplify?
Yes.
Maybe, right? So check for simplifying here. The first one, we have square root of 6. Does square root of 6 divide by any perfect squares? No, because 6 doesn't divide by 4. So 5 square root of 6 is simplified. What about 18? Does 18 divide by any perfect squares? 18 divides by what? 9? 9's on my list, right? So we do want to simplify this one. So, okay, 5 square root of 6, I'm just going to carry down. Square root of 18. You said 18 divides by what? 9. 9 times what is 18? 2. And we picked 9 because it's a perfect square. You may have been thinking 6 times 3. 6 times 3 doesn't do anything for me. They're not perfect squares. Okay? So, I'm just going to keep carrying down. 5 square root of 6. What do you know about the square root of 9?
3.
It's 3. That's going to go out front. What do you know about the square root of 2?
Yeah. Stays 2.
Stays square root of 2, doesn't it? Okay. Am I adding?
You're done.
Okay, I have a square root of 6 and a square root of 2. They're not like terms, so we're done right here, and you're leaving your answer like that. Now, let me comment. Did we have to simplify? Yes, you do still have to simplify. So just kind of be aware there that even though nothing ended up adding together, we still had to simplify. Okay. Let's try at least one more here. Got about 5 minutes. I think we can get definitely at least one more in. Okay, part B, or question B. Cube root of 7 times 2 minus the cube root of 49. What do we have to do to get ourselves started?
Distribute.
We're going to have to distribute, aren't we? That cube root of 7 is going to distribute to both terms. What do you think the cube root of 7 times 2 is?
2 cube root of 7.
Yep, pretty much just stick them together. So 2 cube root of 7. I'm going to carry my minus sign down. Cube root of 7 times cube root of 49. Cube root of 7 times 49, which I'm being told is 343. Okay. I keep going to this blue paper. Maybe you don't need the blue paper, but I think it's helpful. Cube root of 7. Can I do anything with cube root of 7?
No.
Not a perfect cube. It doesn't divide by anything here. Okay, cube root of 343. Can I do anything with the cube root of 343?
Yes.
Oh, guess what? This doesn't happen often, but it's on my list. It is a perfect cube, right? What is the cube root of 343?
7.
You count down 2, 3, 4, 5, 6, 7. Okay, so 2 cube root of 7 stays, minus cube root of 343 becomes 7. Outside of any radical, there's no radical there. And now what?
You're done.
Circle it, we're done. Okay, we have a radical, a cube root of 3. We have no radical over here, so we cannot go any farther. You're done right there. Okay. Okay, I'm going to pause this there. We'll pick up tomorrow on C and D. Have you looked at C and D? What are we going to have to do? FOIL. Yep. We'll be talking FOIL on C and D, and then we'll be talking about how to rationalize these denominators on the backside. Okay? So, if we're here for a full day tomorrow, you might get some work done.
Yeah.
Okay?